Hi everyone, I welcome you to this session on low-code visual testing. I'm Lucas, the founder of LogicFlow, and
That was a bit early. Hello again to the tools track um, of the TestCon conference. I'm Martin Gijssen, and I will first introduce the speaker. Lucas Fievet is from LogicFlow in Switzerland, and he will explain and demonstrate how computer vision based on artificial intelligence can help with the creation and maintenance of enterprise test scenarios. And it will be interesting to see how artificial intelligence is finding its way into our profession more and more. Please remember that Packard and Manning are awarding ebooks for active participation, so send your questions in the chat and rate the session afterwards. And now I give the stage to Lucas for his talk on low-code visual testing of an enterprise scenario. Thank you.
thank you very much. Sorry for the early start. So thank you for the introduction. Yes, I'm Lucas, the founder of LogicFlow, and we're building a tool called Astra, in which we increasingly leverage machine learning and computer vision concepts to speed up and facilitate the creation of end-to-end test scenarios on web applications. In particular, today we're going to see how to eliminate weight engineering. It's a little bit more advanced for visual testing. One needs to make sure that the page is really fully rendered and stable. So it goes a bit further than what some frameworks like Cypress or Playwright do to wait on the next element to be ready to execute the next action. We'll see how with machine learning, the need for selector engineering is very much reduced and eliminated. And with visual assertions, one can assert like larger pieces of a web application of a screen without having to assert individual elements on the page. And the machine learning algorithm, when there's changes in the web application under test, will automatically search for the element that was previously clicked and update the test case accordingly. So what is the low-code engineering progress? We break it down into four parts. Is first to have a tool that allows in most cases to do no-code test creation without writing any code, that abstracts away the weight mechanism, doesn't need to wait on any specific element on the web application, can add visual assertions with computer vision to assert an entire screen, including layout and styles, and really track any changes that occurred across releases. And that makes autonomous maintenance. When the web application changes, it will automatically search for the element on the page visually and update the selectors. So what's the objective of low-code testing in a nutshell? The goal is always to reduce the effort to create accurate production scenarios. For this, we'll have like a various no-code test tools. The goal for more advanced scenarios is always to create as well, be able to export human readable and maintainable scripts that can be extended by test engineers, and always with the goal to automate the test cases for the application or test, including maximizing the assertion coverage and minimizing the maintenance effort for the test cases. How is it often done today? To the right still is an example in Selenium. There's a lot of for loops that need to be added to, or wait for the element to execute the next action, for that element to be present on the page. The selectors need to be carefully engineered by XPath or with technical IDs or classes and tag names. One needs to assert various elements on the page one by one, like here on the right, there is a table, and one asserts the full name, the email, the company name, all individually, and it creates a lot of code that needs to be written in the first place and then maintained subsequently. And the more code there is for selecting elements and creating assertions, the more intensive the effort is going to be as the application evolves. So how do we simplify this? Is we eliminate the need for weight engineering entirely. There's a computer vision algorithm that monitors the page readiness. It's really the visual level, so it doesn't just check for one element to be ready in the page. It really monitors the whole screen, which then allows to get high quality screenshots that can reliably be used for visual assertions, which is the next point. Whenever possible and there's no dynamic content, we use visual assertions that just assert entire elements on the entire parts of the screen. For example, an entire table and not just like individual elements in text, and doesn't only assert the content, it really asserts the layout and style and colors and everything at one, and one can really track any change on the web application. With the no-code test tool, selectors are created automatically. All the information of the clicked element are tracked, so not only the Selenium selector, or like a technical selector, but as well like the size of the element, its visual aspect, its location on the page, and other properties are being tracked, which then are used by the machine learning algorithm to find the element again in case it has changed in the DOM structure or location on the page. And last, with the maintenance, with the computer vision algorithm, resolves automatically the selectors when the application evolves. And with these various utilities, we can simplify, so it's the same script that is shown on the left, but using machine learning. We just create a full snapshot of the initial page, search for certain elements. This is abstracted, then a way to have the machine learning algorithm work in the background in case the ID of the element would change. And then one could, for example, assert the whole page again once one has searched for the contact here on this page. So to give a bit more context here, it's a table with a search for contacts from Microsoft Dynamics custom relationship management tool. That's what we're going to do in a live demo right after. And the whole checking that the contact has been found can be reduced to a single line, which is then much easier to maintain if, for example, the table structure would change in the application. So is it worth a try? A lot of companies still like to, are more comfortable just programming all their test cases. We think it's worth a try to make it possible without code or minimize the amount of code that is written, and so bring a significant productivity gain to creating test cases. So in the part one, what we're going to see is the autonomous wait mechanism. How does it work? First, we have a virtualized recording that is cloud-based with execution through Selenium. So we don't directly record in the browser, but only through a virtualized interface, which guarantees the replay. And there's a machine learning algorithm behind that not only takes the screenshot, but it takes the reference screenshot from the recording. So the first time the scenario is recorded, it keeps track of all the screenshots during the recording. It keeps track of the DOM structure. And then when re-executing a test case, it compares these against the current screenshot or the previous screenshot during the execution, and will predict if the page is stable or not. This allows to give very good real-time feedback on the stability and readiness of the page. The network is trained to handle like changes in dynamic values, changes across different browsers, and differences in environments and in screen size to some extent. And the whole iteration can be done in around 40 milliseconds. So you can iterate very fast and get a very precise timing of when is the page ready. Here's a small example, typical example of an e-banking. After logging, the page here needs quite some time to load. And during the recording, the final state of the page here to the bottom right has been recorded and tracked once, and the neural network will just keep iterating in like 40, 50 millisecond intervals to check the state of the page and compare it against the expected reference state, and only continue once the page is ready. Now this issue is much less and less an issue with a lot of frameworks like Playwright and Cypress that already do an excellent job at automating the weight mechanism, but with frameworks like Selenium, it's still a major challenge, and especially for visual comparisons, the final state needs to be impeccable. We cannot just work with screenshots that are partially rendered, or maybe the next element to be clicked is already there, but the page is not yet fully ready. So that's why we need this machine learning algorithm that really tracks in real time the page readiness as a whole. The second part is the autonomous maintenance. Here we, during the recording, track all the properties of the elements that have been interacted with at a certain action. And when that element is not found, the machine learning algorithm kicks in. It creates a list of all the DOM elements on the page that can be interacted with, and evaluates the element during the recording or the last execution against all these candidates and calculates probabilities that this is the correct element to be matched. And it keeps going with the highest probability element, and if then the test case at some point no longer continue, it would stop. But most of the time, for all the changes in application just related to DOM structure or minor changes in the layout, this automates the whole maintenance aspect. And that's what we're gonna now show in a live demo. So this is Astra. I already pre-recorded the things just as a fallback. We're gonna do a live recording. So here we have a to-do app that's just for showing an example. In particular, gonna focus here on this menu below. Here it's written with a list in HTML, like it uses list elements. And we're gonna show what happens when we change something. So in Astra here on the top left, we have the cases, test cases that have been recorded. On the second level, for each test, there are the executions of that test. And at the bottom, we can see the different steps. So we're going to record a scenario here, like it's already pre-recorded. We're gonna add an item, go through the active items, completed items in the to-do app, clear the completed items, and that's the scenario we're gonna record. Can now do this here by simply starting a new recording. I'll call this maintenance live. Now what happens is that on our cloud, it starts a browser with a Selenium driver, and we can interact here virtually through the browser. So that the screenshot here simply with all the elements, and it sends these events to the server in the background. Go through these elements. It's our scenario. I need to stop this. Well, here we have the recording we just did with all the screenshots. In our case, we can add various annotations that we're going to see later on, in particular for visual comparison. I'm going to replay this once. And then what's going to be interesting is that we're going to do replay on a modified to-do application. So we have a second variation where we renamed elements on the page quite a bit. So here we actually translated it to German, so the text in the fields here has changed. The structure, DOM structure is no longer a list, it's like div and span elements. There's no technical classes have been renamed, there's no technical IDs. It's just to demonstrate that the machine learning algorithm that is behind the scene in Astra will really go and search visually for these elements. So I'm going to replay this now against the other URL. We'll leave all the other settings the same. So what happens now here is that this one button, clear completed, disappeared entirely. It was removed. So the machine learning algorithm now brings us into a mode that lets us interact. It doesn't just skip it. Here it shows us the baseline to the left with what was previously clicked. Here the clear completed, and we can see it's missing. So we're just going to confirm that we want to skip this step. And now we have maintained our scenario, and we can see here there's various events that happened. The first 3 steps just executed normally, and the 4th step here, it couldn't find the active button because it was renamed and modified in the DOM structure. And so the machine learning algorithm started comparing the previous button against all the elements in the page and found that this button here was the most likely with a probability of 91%. The same here is even lower because the text is quite different. It's only at 62%, but still the most likely element. That's correct. And here we can see one manual interaction that has been done to skip a button that no longer exists. And now we're going to set this as our new baseline. So this is the new baseline that we're going to execute. You can think of this as like, let's say, release 2 of our application. And if we now replay against this baseline, the second run will just run through properly, executing exactly as was in the previous baseline, and that's how we do a maintenance without going into any code or having to do much effort for it. Go back to the presentation. So to summarize, we had what we just showed in the live demo was this to-do application, which had a certain DOM structure here and the buttons below. So technical IDs, if you're not in control of your application, for example, is very important. Text have been translated, the CSS classes have been renamed, and there was different DOM structure. Nonetheless, based on the size and location and visual aspect and relative location on the page, the algorithm correctly identified which buttons to click, active to active and completed to erledigt. And we did a manual maintenance step to confirm that we want to skip the clear complete button. So now we can go to the next part. Part 3 is the visual assertion engineering. Here we can, again, let's look at the simplification that it brings. That's already like mentioned at the beginning of the example. Here to the left, we have this scenario where we open a page with different contacts, and we want to search for a new contact and confirm that this contact has been found. And it requires a lot of fetching elements on the page, different labels, asserting them one by text. And all of this can really be simplified with 2 snapshot statements that will provide full coverage of the page in a visual scenario, and really significantly reduces the amount of code that is needed to check these pages. We're going to show this with a small example on the to-do application. Again, I'm going to take the recording we have and rerun it on a modified application and see that it automatically identifies all the changes on the page and show how we can confirm them or then, for example, report bugs. I'm now going to switch back into the application. So we already have a to-do app. I'm going to go for the bulk version of that same application. So color has changed, title is off. There's been some text that's been bolded here. And first of all, right now there's no screen is asserted visually, but we can activate this through the menu. Now we can confirm that this step here is to be checked visually. We want to check at this stage. Here, I'm going to rerun this. And now we can see that the test case here has some warnings of visual changes that have been detected in the application. And with the comparison against the baseline, we can enter into this mode side by side, where we can see the baseline state that's been executed and the current state. And in red, it marks us all the changes that have been identified. In particular, the to-do application here on the to-do title here has been modified a position and went to the right. And we now have the possibility to label these changes. For example, let's say we truly wanted to have the title on the right in purple. We could say this is an expected change. And it would now go into the database as an example of something the machine learning algorithm should ignore on this particular application. And it would be retrained overnight with this new example. So this allows to customize and train the machine learning algorithm for particular applications that you're testing. Now, if we just wanted to confirm, for example, let's say that all these changes are wanted, we could just go here, set this as a success, create a new baseline, and then just rerun against this new baseline, and it would compare against this new baseline that we have created. And now we see there's no changes because it compared against this new baseline here, and there's been no changes in there, and the test was successful. Now we get to the fourth part. It's the export that we're working on. It's still a work in progress, but it's useful to extend test cases. So what happens when it's to assert specific dynamic values? Let's say we're testing an e-banking, and in a payment screen, we want to check that the currency change rate has been correctly fetched against some external API and is properly shown in the UI. These sort of API calls and checks need to be added into the recording. So there, Astra allows a easy customization system where the low-code test tool here to the right can generate page models. These can be regenerated at any time. The test case itself is using these page models, and the developer, the test engineer that will now extend this test case can go and create extended page models, override some methods, add some methods, for example, asserting a certain value on a page against an external API, and then replace the usage in the test case of certain page models with the overwritten page model. And if the test case changes, all the maintenance can still be done in the low-code tool, and all the page models can be regenerated without affecting any of the customized code, which makes it very simple to keep all the benefits of the autonomous maintenance with additionally all the customization that has went on top. So here's a sort of example. Here there's a page. This is the to-do application again. It didn't only record the one action that has been clicked here, the clear completed in this case, but the page model already contains actions like pre-recorded actions, methods for like the active button and all click, and one can access all the different inputs and elements on the page. And here's a C# example, and one can create a new class that would inherit from this page model and then extend it with API calls and other maybe setup calls that are needed. So now we're going to wrap up everything. We're going to put all the elements we've seen together and automate a scenario on Microsoft Dynamics CRM in the tooling. So here's already an example of the scenario. I've already done a bit of setup and automated the login command to speed things up here during the live demo. So we're going to log into test account of Microsoft Dynamics. Go to the contact page here, search for a certain contact on the upper right that is not available, that's not found. We check that the user is indeed not found. Then with the scenario, we're going to create that user, give it this name, give it its name, this new with a date, save and close, then search again for this user, check that it's been found, and then delete it again so that the test case can be reproduced. So I'm going to start a new recording, call it live again. So in our tooling, there's a keyword-based approach where after recording, one can cut out various pieces. Here, for example, we have cut out the login command, so one can just replay entire commands and doesn't have to type passwords and usernames every time. And this is gonna get us to the selection screen of the different apps that are available. We're going to select the custom apps here. I'm going to use something here on the clipboard. We're going to go to contacts. Here we have good loading examples that need to be properly awaited. To search for this user. It's not found, so we're going to create it. Going to give the last name and first name as the required fields, but could extend the scenario by adding more inputs. They would all immediately be available as parameters and could be parameterized to create variations of a certain test scenario. And now we're going to save and close. Clear the search. Search again, user is found. I'm going to select all of them and delete it again. So then we're going to stop the recording here. So that's our new MS Contacts live recording here. We see we executed the login command, selected this custom, went to the contact page. Just going to check step by step that the recording does what we intended to. Search for it, created the new one. Also, this placeholder here with this format now, this will be replaced dynamically when re-executing with using the current date time. Clear the search, do the search again, and then finally delete the user. So now maybe we want to add some assertions. So like we saw earlier in the to-do app, we're going to go to maybe here when we arrive on the contact screen, we want to assert this. And we, for example, want to assert that the user we use to execute these test case scenarios has the proper menu option and doesn't have any permissions or menu entries that he shouldn't have. So here we now with the I here activated the comparison of the entire screen. And in the UI, we can now restrict this comparison, for example, to just check the menu. And if there's any changes, we don't want to fail the test case, but we want to get a warning to be aware if that user would have gotten any additional rights to execute something. Here on this page, we want to assert, we just assert that there's no search result, not found. And if there was some user that was found, we want to fail the test case. And here on this level, we want to assert that there's exactly this one new contact has been found. And that's it. So this is how we can include, like, restrict the comparison here. We can assert this entire menu with one visual check. If there's dynamic values, for example, want to assert the entire screen, when there's the possibility as well to exclude paging, we can exclude this. For example, if the number of pages in the database changes, we can explicitly exclude such information to avoid any sort of false warnings in the visual changes. That's another useful feature. Now we're going to replay this. This page load here is just a bit too slow. Oh, I think we clicked, my apologies, I think we clicked the wrong app here. We'll try again. Okay, so wrong. So here we now have an example of a test case failure, actually. So what happened here at the beginning is the page here is really quite slow for this test application to load. Where it's 20 plus seconds, so we run into the timeout, and even of the machine learning computer vision algorithm, but we can still increase this manually just to make sure that it would wait long enough. The machine learning algorithm for the page stability is especially used here on the checkpoints, on the visual checkpoints, to make sure that the page is stable and allows for a reliable comparison. So we can see, for example, the menu was correctly passed, it's identical. Here there was no element found. But here, compared to the recording, when the recording had the placeholder, here the name changed because it's been replaced by the dynamic value. And that's why here the test case failed, but we could set this as now success. Set this as the new baseline. And now if we replay this again against this baseline, it should then be passing. Another test scenario here is green. See here, even on the last step, the screenshot was properly awaited, is stable with the loading, and the name was exactly as expected, and the whole test scenario passed. And if there was not any additional results found here, the test scenario would fail. Now we can wrap it up. So what are the advantages? The generated code in Astra is sort of following a Swagger-like concept. For those who know the API, open API standard, for it's creating like an open end-to-end standard for page models and easy to customize. With the no-code or low-code approach that only writes code for when customization is really needed. It's much less code to maintain. The AI drives the maintenance when there's layout changes or structures in the DOM of the application. The execution on a good machine here, the Microsoft Dynamics example is a bit unfortunate because the application itself is very slow for these demo accounts. We should use a faster application, but the execution speed is fast. And with the checkpoints, the visual stability check is reliable. It waits for the screenshot to be revealing for the application to be fully rendered. It's very easy to increase coverage because with a single visual assertion, one can assert a whole menu bar with like dozens of elements. Nothing escapes, even if there's breaking changes in the layout or style. One can easily collaborate with developers and technical users because we can add annotations onto the screenshots easily onto the elements and share them directly on the results. And there is a CI/CD integration via command line to execute this on any change of the app. So we achieved the 4 goals we set ourselves is eliminate the weight engineering to get really stable screenshots, minimize the effort to create asserting entire parts screens of the application. There's no need to write repetitive code, and maintenance effort is minimized to cases where really the whole workflow would have been changed. So no, is this the end of writing test code? No, but the effort is greatly reduced. And thank you very much for your attention. And I herewith open the QA session.
Thank you, Lucas. That was a very interesting practical application of the use of artificial intelligence in the area of testing, in this particular case, automated testing. There are some questions that came in, and these are about, for instance, Stefan Teslai asks, can we run the recordings in parallel mode to save on execution time?
So the question is if the test cases can be executed in parallel.
Yes.
Yes, they can. So on SaaS deployment in our cloud, execution is fully elastic. So depending on the purchased plan, one can execute as many test cases in parallel as needed. And for on-premise deployments, this is just a matter of adding enough agents that will run the test cases.
All right. Thank you. And Dustin Altman asks if you would tell the algorithm, the machine learning algorithm, that a title being purple, red, or blue is okay and it can be ignored. If you say explicitly these colors, would it then also accept later green or whatever other color, or how does that work?
No, in this particular case, it would be quite color and text sensitive. So we have, so it would be it would learn that for this particular application, a change to a purple title has been okay. So when there's other changes towards purple, it is more likely to accept these changes. But red or green would then still be flagged as something to be looked at, unless the title was already green, of course.
Aha. All right. So that's. We have more questions still. Judith Rosenberg asks if does it visually validate against elements that are displayed only on hover? Because of course they're not always displayed. So how does that work?
I haven't shown such an example, but in the recording mode, there is a right-click menu where one can add like mouse over events and double clicks, right clicks, also sort of less common but needed events. Then one can trigger a mouse over event, trigger the hover, and then select the hover in a screen to be asserted. That's possible.
Okay. The final question was asked in the chat is by Vaklavas Pseudakas. Have you met any problems with things like drop downs and also hover actions and other, I guess, more exotic elements that you can have in a web page?
We did run into challenging, like date picker elements have been quite challenging sometimes. There we have various ways to handle them. That's something we're in particular working on in our standardization to simplify the handling of these advanced elements. Drag and drop support is something that's going to come shortly, and then typically file upload inputs have made some challenges, but everything else so far has all our user base is working very well.
Do you anticipate that there will be elements that cannot be handled in a nice way at some point? Or do you think that all these challenges can be resolved?
We are firmly believing that all the challenges will be resolved in the coming month. I mean, there's only we have now more and more new applications that we're testing, and except for the cases already mentioned with like file uploads and downs, we have not encountered more known issues at the moment. So we're working hard on making it work on any scenario.
Interesting. Another question, when are manual actions still required when you're either creating or maintaining such scripts?
So at the moment, when the work, let's assume for example, the flow changed, the scenario really changed from the logic, and the machine learning algorithm cannot find a matching element at a certain threshold. Like we do a cutoff at 50%. If there's no element that matches above 50% based on the previous baseline, then it enters this manual mode where the user has to or confirm the element or then skip or introduce new actions that are needed. So in short, the manual mode is always needed when there's real change in the scenario that really needs to have some application knowledge and business knowledge to adapt the test case accordingly.
And you referred also to keywords being used. You showed the login as an example. That is also a manual action, I suppose.
So here I can briefly show. So this is a way for the user to then create these in the tooling. It works like this. We could, now I already have the login here is done, but we could say, for example, go to contact page, has these two actions, and we can create to contact page. And we can create more commands like this and reuse them during recording to simplify the recording process, or just build new test cases with these building blocks. So that's something, yes, the user cuts these building blocks out himself to then facilitate the building of further test cases.
Okay, great. Thank you very much. That brings us to the end of the scheduled time. So thank you, Lucas.
Thank you.
Again, a reminder to rate the session for a chance of a nice ebook. And after the break that is now coming, we'll be back with the next session. Thank you.